give us and Anne kind of like a rough idea. She's gonna put on a poll on if you think you have the Zoom version that's updated enough that you could do the self-selecting breakout rooms. So just go ahead and respond to that. That should just come right on your screen now.
I thought I had upgraded. Kent, are you saying that if we have upgraded, we should be seeing something on our screen by now?
Right now, all you should see that's new is the poll.
Okay.
Okay, I think everybody has included their responses. So I'm going to end the polling, and it looks like the majority have upgraded their Zoom version. So while everyone gets started with the presentation, I will go ahead and configure the room so that actually the numbers are changing a bit now. We will go ahead and try the self-selection today. Hang on just a second. These are actually changing as we speak. So again, the poll question on your screen is, did you upgrade your Zoom to the latest version before this meeting? If you upgraded it, please select yes. If you did not upgrade for whatever reason, please select no. Okay, it looks like we can still go ahead and try this. So what that means is the 20% or so of our group that did not, that was not able to upgrade, you will be stuck with me in the room for a little bit after everyone else selects their rooms, and we'll have to, I guess, one by one, send you into your proper team. So I will just stress again, if you could please put your team name after your name on your screen, it will make it that much easier for me to assign you to the right teams once we get time to break out.
Okay. Thanks, Anne. And we'll go a little bit more. The long and short of this is that we know that many of your teams are now getting to the point where you guys are working on multiple aspects of the project. And so these breakout room, new self-selecting breakout rooms will allow you guys to basically break off into a smaller group if you need, a few people to work on a certain thing, and then, a few more people work on different things. So that's what this is for. If your team hasn't got to that point, or you don't need to get to that point, then it's the same as the meetings before. You'll all be in the same bigger room, and it's creating additional rooms so that you can go into these sub breakout rooms. So that's sort of the reason behind it. So let's get started. So again, reminding to all the seniors, scholarship application is now open. It is due on April 15th. If you're a student here who is a senior, really encourage you to apply for the scholarships. It's very straightforward. You do need letters of recommendation. So again, April 15th, that's a little over a month away. It is tax days for those of you students who start working part-time. So it's tax days for us mentor as well. So you want to ask us early, because you'll be battling your time and requests with us and our taxes. So make sure you as your mentors early. Okay. Team leaders, make sure, and students as well, the way you do it is you just go to the national database, go into your profile there, you should see a new item, line item on the left side says scholarships, and then that's how you apply. If you don't see it, you're a senior, check with your team leaders. Usually what it is that your team leader just needs to mark you as active in their database of the online website, okay? We had the homework, and had the homework last time, or last meeting, about the writing the letters. Thank you to the Miller Foundation, who has supported our scholarships for the past few years now, and they have continued to also help us for this year, you know, with COVID and all, which is really, really, really generous of them. So we have two students that I want to announce that has submitted and will get the gift cards from Ann. They're $25 gift cards, and that student is those two are Rawan Saab and Amelia Juarez. So congratulations to you guys. I want to add that we have 5 gift cards available. So if you still want to write something and, you know, show your appreciation and get that $25 gift card, you got 3 more to go, and Ann's is generous enough to allow you guys to do that until tomorrow. So first come, first serve. So we got 3 more slots if you want a 25. Obviously, if you just want to write a nice letter, please do that as well. Okay, bye. And congrats again to Ravon and Amelia. Another good news. DPR is a general contractor. They have a summer 2021 internship program specifically for high school juniors, seniors, and high school students who are graduating this May. So it's specifically for you guys. It is a paid internship that goes on for about 8 weeks. That is full-time. So it's really, really good opportunity. I want to share that with the juniors, seniors, and graduating seniors. We'll send you guys, what I should do is I will attach So you guys give me a sec. I will attach the actual full document application that has the applicable link into the chat here. So you all will have it. Pardon me, bear with me for a sec. Forgot about that portion. Okay, you should see in the chat room. That's the full application and all the information you need to know for the eligibility and the requirements for the internship. So again, really awesome news. Paid internship in construction, and even if you're interested in architecture or engineering, it's still a very, very valuable internship.
Kent, I don't see it in the chat. Maybe you accidentally sent it to someone specific.
It should be there. It's sent to everyone.
Yeah, it's a PDF. I see it.
It's a PDF file. I will send again just to.
I think you can't. Some people can't see it because the PDF's meant for computers, and some people are in phones or on Chromebooks.
Okay.
So try to send like the website link for it.
I don't have the website link, but Anne could follow up and send a follow-up email to everyone on this internship. Okay, so that one is due April 16th. So for all intents and purposes, it is also due on tax day. So keep that on your mind, especially if you're seniors graduating, getting your A scholarship and a summer internship. That's a pretty good deal. Okay, a little bit more schedule outlook. Today we're going to start talking about engineering. Today is going to be the engineering breakout session number 1. We're mostly going to talk about structural today. Little change in our programming. Next meeting, which is the 25th of this month, we're going to have a short meeting. That's because we have the ACE Spotlight event at 5 p.m. That's one of our big ACE event where we essentially have a spotlight event where we have guest speakers. And the whole goal of the event is to get you guys more scholarship money. Normally it costs $100 per seat to go to this event. Again, like all that money goes to you guys' scholarship. This year being virtual as well, you students are more than welcome to join us. You basically just go on the acementorla.org. You see the link there, you register as a student, and I think it just takes your student email to verify, and then you're done. So if you're interested in that, be sure to sign up for that as well. It's a pretty cool event. We have a pretty cool guest speaker for that. So yeah, so because of that, it's on the same day as our meeting, so we will kind of cut our meeting short on that day. And then what we're going to do is we're going to add additional meeting the following Thursday, and that will be the engineering breakout session, the official engineering breakout session number 2, and we'll cover that for the mechanical, electrical, plumbing, and the sustainability.
Can we offer for that spotlight, Ian just put it in the chat box, that we'll offer a free seat to a student, but a teacher as well.
Yes. So students and teachers are definitely welcome to attend. I think it's a wonderful event. It's been awesome every year. This year's being virtual, so you know, it's even more interesting. I'm excited to see it. And a little bit more on that, the guest speaker for the event is Tarek Mosa. Sorry, obviously I haven't watched Flip or Flop, but I heard about it. So the host for Flip or Flop is our guest speaker for the event. And again, that's from 5 to 6:30. Essentially, it's right after our next meeting. Similar, again, today's session, just like last session, will stay on. The ACE host will stay on. So your team could be there as long as you want, as you need to work on the projects. Okay, with that, I want to quickly get into the structural engineering aspect today. So you're probably looking at this and, you know, why is this giant table? I don't know if any of you have been to the Broad Museum in downtown LA. If you haven't, and when you can go, once everything's opened up, I highly suggest you check it out. It's right next to the Walt Disney Concert Hall. And there's literally this art piece where it's a giant table where you literally could walk under it. It's almost like Alice in Wonderland feeling. And you might be asking, you know, what's the table has to do with structural engineering? And then when we talk about structural engineering, you usually talk about earthquakes. And I usually realize when you talk about earthquakes, most of us think about the movie San Andreas with Dwayne "The Rock" Johnson, or you think about the Earthquake, the song by Tyler, the Creator. So the earthquake we're talking about is more about building design and how more, by the end of this quick presentation, you're gonna see it really understanding how that table works on the left is understanding how the building is framed on the right. So before we get into the weeds of it, I sort of want to show the quick report video here of the Ridgecrest earthquake that just happened, just a year and a half or so.
A lot of different businesses in town caught those in.
Oh, is it not playing? Let me go back.
A lot of different businesses in town caught those intense first moments of this earthquake on camera. Behind us here at the East Ridge Market, they had hundreds of bottles fall to the ground and break. The business next door is a laundromat where the ceiling collapsed on the inside. But we also just got that new video into our newsroom showing those really scary moments for those school children who were on stage enjoying their holiday when this earthquake hit. Take a look. A children's 4th of July performance comes to a screeching halt. Parents filming hit the floor at Burroughs High
Awesome.
School the moment a 6.4 magnitude earthquake hit near Ridgecrest. The several seconds of violent shaking did tens of thousands of dollars in damage at the East Ridge Market.
The more hands, the better, so the cleanup goes a little faster.
The family-owned business has been cleaning up shards of glass for 10 hours. But they're not at all concerned about the inventory.
You care about the well-being and safety of the employees and whoever's involved.
But Christian Catlin was the only one at his business when it hit.
Our inventory got absolutely destroyed by it. It was a freight train hitting our office.
Just like that, $40,000 of computer parts came crashing down.
It wouldn't stop. It just kept rolling in waves.
Most of the damage was done to things that weren't secured in one spot.
I thought my house was collapsing on top of us.
Things like Bridget's mobile home of many, many years, now knocked off its foundation. She's now homeless.
That's a very scary thing.
So is the family who lost this home to fire after the earthquake rattled their gas lines. Caitlin still has a home to go home to, but the ceiling collapsed, terrifying his 4 kids.
Tremors were nonstop. We actually got in the car and were thinking about leaving.
And the owner of these 2 businesses tells us that nothing they lost will be covered for them because they don't actually have earthquake insurance. They tell us it didn't seem like a necessary investment at the time, but now that they've experienced this earthquake, they realize it probably would have been a good investment. Reporting live from Ridgecrest, Nicole Comstock, CBS 2 News. Good investment.
Let me reshare the screen here.
Looking like.
So, you know, the interesting about earthquakes is that it's relatively a rare event, but when it does happen, you know, it's pretty catastrophic. And in Ridgecrest, you know, that earthquake is pretty bad, but it's really not a big one. And you know, when we're doing building designs, earthquakes, things that, you know, some of us in our lifetime hasn't even felt one yet, is actually a really big issue, because when it does happen, you know, you want to be prepared. And earthquake design is, interestingly, when we think about earthquake, a lot of times we think about, right, San Andreas, California, but it's actually a pretty, you know, in here in our country, it's kind of like covers majority of our country. Most places not severe as California, as Los Angeles here, like this map here. You can see the severity of earthquakes, you know, going from the purple, red, which are like the most severe, like the biggest earthquakes you'll see, to, you know, green, blue, right, less severe. It's not as bad, or, you know, the highest earthquake in those areas not going to be as high as the red zones. But my point here is that, you know, you can see on this map, majority of the country is in an earthquake area, in some way, shape, or form. So it's actually not a very localized thing. So knowing key things about earthquake designs, is very vital to our profession and, designing houses, buildings, bridges, and so on. So today we're really going to talk about the main key on earthquake engineering, structural engineering, and that's 3 items. When you're designing you guys are designing your buildings, your structures, there's 3 things you want to address. Number 1 is racking of the building. Number 2 is sliding of the building. And number 3 is overturning of the building. Racking is sort of like what you can see in the image is, it kind of starts swaying back and forth, right? And buildings they're not solid shaped material blocks, right? They're a bunch of little pieces connected together. So things wants to flex and sway and, rack and move. And we have to be able to accommodate that sort of movement from an earthquake. Next, let's say it is strong enough, it may just slide off. So we want to make sure that your building, just like in the video we saw earlier, the mobile homes, doesn't just slide off its foundation. So we want to make sure that we find some ways to make sure we address that. And then lastly, similar to sliding, maybe it's prevented from sliding, but it overturns, right? That happens all the time. You think about, when you're trying to move your refrigerator, you're dragging from the bottom, right? And you might not, and then you're dragging on carpet, right? So the carpet is helping you from sliding, but that fridge, as you're trying to pull it, it's going to tip over, right? So that's the overturning effect. Similar thing happens to buildings. So let's address the racking portion first. So in structural engineering, we usually more or less comes down to these 3 main type of what we call seismic systems. The top one we call moment resisting frame, which is basically we designed the beams and the columns connection to have as I'm kind of showing you, almost like a nice, really strong handshake. So that way it's the joint themselves, the connection between the beams and column that's preventing the racking or controlling the racking from being too excessive. The second option is a brace frame. There's a second picture. That's the rods or the triangles in red. Those of you who've been with the ACE program and done the bridge competition design, or if you've done any bridge popsicle sticks, you'll find triangles usually is a pretty strong geometry, and we do the same for building, using sort of the triangle formation to help strengthen our building. So that's the second option. The third option you'll see mostly where you guys are living right now, in your house, in your apartments, what we call shear walls. Could be wood, could be concrete. So we create a really strong wall in order to stiff up the building to make sure that it doesn't do the same sway. All 3 has their pros and cons, structurally and architecturally, and amongst other disciplines in engineering and construction. That's something you guys want to talk about with your team, with your engineers and your team. But these are the main system that helps us on the racking of the building. Okay. Sliding. So just like the video we talked about, in the video for the mobile home that you saw, the main failure of that was it slid. It slid off its footing, it slid off its pedestal, and it fell over. That's actually a very common seismic phenomenon for these buildings, not just mobile homes, but regular homes. If your house or your apartment has a crawl space below the floor, you might have a similar issue where the house themselves sitting on a crawl space on this, what we call them cripple walls, is not attached to the foundation, which is pretty common back in the old days. So a strong enough earthquake that could happen could actually cause the structure to slide. For our projects, because we are doing temporary structures and designs, this may be something that you want to consider as well, right? If you're designing, let's say, a modular building to sit on the ground, the question becomes, how do you stop that from sliding around? So you want to address that aspect. Lastly, just like what we talked about, like a fridge, pulling a fridge over a carpet, If it doesn't slide, it's gonna want to tip over. Same thing for buildings, right? Because you prevent it sliding doesn't necessarily mean you prevent the building from moving. It may still tip over and cause an uplift. In this case, what the picture you saw here, or you're seeing here, is for mobile home as well. So mobile home has similar issues. Sometimes it doesn't slide, but it tips over. And in that case, the way you resolve, in this case, what you do is what we call kind of like a tie down or a hold down, where you literally strap the entire building down and then anchor it to the floor and, you know, do some sort of drilling into the ground so you could hold the entire structure down. So those are the main three things. Okay. Little little points on design for sort of kind of like an efficient structure. You want to be identical on your both axes. What that means is, you know, if you have 4 walls to your buildings, you want to make sure you have those seismic frames on all 4 of those walls, but also on both sides. So, you know, it's this way and this way, right? That way you capture both direction, both what we call orthogonal direction, which is the primary. If you could capture at least this one and then the other way, 90 degrees, you're pretty much covered to ensure that your building is stable. Identical vertical resistance, what that means is you want to work with your team to figure out, hey, you know, maybe you want to do a strong shear wall on one wall, but then you're going to do a moment frame on another wall. That may work, and that's when you guys can talk with your team. But more often than not, you try to not mix and match the system. You can, there are ways to engineer around that, but that's something you want to, you know, it's a point of discussion in your talk with your team. And then I'll skip the third, but the fourth one, the locating seismic elements of the perimeter. Usually, more often than not, having these frames, whether it's brace frames, moment frames, shear walls, you get more bang for the buck if you could locate them towards the perimeter. Again, all these are starting points, and it's up to you guys to kind of talk this through with your team and to come up with, you know, your creative solutions on keeping your design stable, you know, and safe. So let's go back to this table that we first saw. So how does all of this work for this table? How is this table should be designed to prevent racking, sliding, and overturning? So let's go with racking. Essentially, when you look at this table, and it's actually true for a lot of tables you have at home, what you'll find is you have the perimeter beam, so to speak, that's attached to the columns. And if you look under most of these tables, you know, even on this art piece and your own table at home, even if, you know, like most IKEA tables follow the same logic, you'll find that the connection between the beam and the column is pretty beefy. You're probably gonna throw in like at least 2 really big bolts to connect them together. So it's not like just nailing it together. And that's to create that rigidity to keep your table from swaying, right? From racking, same thing, swaying, racking. So in this case, this table is using a moment frame seismic system for racking. So about then for sliding, in this case, sliding and overturning. In this case, with this table here, the overturning is not likely, as because the floor is a polished concrete, so it's not like it's gonna get stuck on something, but it definitely could slide. You could see that it could slide if you really push on it. And if there's an earthquake, you know, it's an equivalent of a lot of people pushing on the table. So you want to make sure that the legs of this table is also anchored down to the floor, right? And it is in this case. So that same concept is applied to that art piece, which we would like you guys to consider in your design. So if anything else, these are kind of like the guidelines for your team to talk through for the structural engineering aspect of your project, right? Identify with your team the right lateral resisting system for your project, right? Is it a moment frame? Is it a brace frame? Is it a shear wall? You know, how does that work for your designs and your project? Then present your design on how it would address racking, sliding, and overturning. So I want you guys to talk through within your team, sort of, hey, okay, we got this design. How do we keep from racking? That's the lateral system that you would choose. How we would prevent from sliding, which would be, you know, where would you want to anchor your structure? And lastly, overturning, if you need to provide any hold downs, or is the geometry of the building, you know, is design sufficient enough that you're not going to have an overturning issue. So those are the things that you want to address. And then, you know, in terms of deliverable, at minimum, it will be good. Just provide, kind of like what I just showed right now. You could have an image of your design and label, oh, this is going to be our brace frame. This is going to be where we connect for shear, for sliding. And this is where we can put our hold downs or tie downs for overturning. So it could be as straightforward as that. Okay. And of course, all of that has to be balanced. You know, there's costs architecturally, there's costs in terms of coordinations, in terms of construction, and there's costs in terms of just raw cost number. So those are things I want you guys to have the conversation and, you know, present to us as part of your design at the year-end project. So that's it. That's really all there is to it for what we need structurally. Again, we're gonna have the breakout sessions on, and yeah, that's all we got. So